Hello, everyone, and welcome back. Today, we are going to learn about the embeddings, the fascinating concept that's fundamental on how AI system understand language and its meaning. This might sound technical, but I will explain in a way that makes perfect sense. Let me start with a fundamental question. How do computer understand the words? Think about it. Computer works with numbers. They processes zeros and ones, perform mathematical calculation, and compare the numerical values. But words are not numbers. Car, dog, happiness, these are symbols. They have meaning to us as a human. But to a computer, they are just string of characters with no inherent meaning. This creates a problem. If we want AI system to understand language, we need a way to convert words into a number that computers can process while somehow preserving the meaning and relationship between the words. This is exactly what embeddings do. So, what are embeddings? In simple terms, embeddings converts word into numbers that computer can understand and compare. But they don't just assign a random numbers. They assign numbers in a way that captures the meaning and relationship between the words. Let me explain with visual example of this side. Look at the word apple. In the embedding system, this word get converted into a series of number. Let's say something like 0.25, 0.26, and so on. These numbers might represent hundreds or different dimensions or the characteristics. Now the word banana also gets converted to a number, maybe 0.33, 0.10, and so on. Notice that these numbers are similar to apple, but not identical. The word queen might be 0.51, 0.71, and the king might 0.29, 0.68, very close to each other. Do you see what's happening? Word that have similar meaning or belong to the similar category get similar number. The AI system learned that apple and banana are closely related, like a fruits, and the king and queens are related, like a royal titles. But apple and king have very different number because they represent very different concepts. This shows how embeddings preserves meaning. Closeness in number reflects closeness in concepts. Why embeddings matter? Let me give you a real world example. Imagine you are searching for information about cars. You type automobile maintenance tips into your search engine. Without embeddings, the system would only find documents that contain the exact word automobile. It would miss excellent article about car maintenance or vehicle care because those use different words, even though they mean the same thing. With embeddings, the AI know that automobile and car nearly identical in meaning. Maintenance and care are related concepts. Tips and advice are similar. So it can find relevant information even when the exact word don't match. This is why modern search engine and AI systems are so much better than older keyword based systems. Now, how embedding capture the relationship. Let me give you another example that show how embeddings understand context. Consider the word bank. This has multiple meaning. When we say I went to the bank to deposit money, I mean I went to the physical building where institution performs the financial transactions. But when I say I sat on the bank of the river, it means I was sitting at the edge of the river. How does an AI know which meaning you are referring to? Through embeddings and context. When the AI says the bank near next words like money, deposit, account, the embedding shifts towards the financial meaning. And when it sees bank next to river, water, or shore, the embedding shifts towards the geographical meaning. The numbers that represent bank actually change slightly based on the surrounding context, allowing the AI to understand which meaning is intended to. You must be wondering, how does the AI learn these embeddings? So during the training, AI reads billions of sentences and it learns that words that appear in a similar context probably have the similar meaning. Car and automobile appear in a very similar context, so they should have the similar embeddings. Car and pizza appear in a different context, so they should have a different embeddings. The AI adjusts the numbers, which we call embeddings, for each word millions of times until the words with similar meaning have the similar numbers and words with a different meaning have a different numbers. It's like learning the geography of a language, mapping out which concepts are close to each other and which are far apart. Let me show you where embeddings are used in real AI systems. For example, let's take example of search engine. So when you search for best Italian restaurants nearby, the system uses embeddings to understand that you are looking for a dining establishment, not any recipe or the cooking classes. You're looking for the Italian cuisine, not just any restaurants. And you're looking local options, not restaurants in other cities. Even if restaurant's website doesn't use the exact word best Italian restaurant, the system can find it because the embeddings captures the meaning. Let's take another example of recommendation systems. So Netflix uses embeddings to understand that if you like Stranger Things, you might like other sci-fi movie shows, even if they are not explicitly tagged the same way. The embeddings captures the essence of what makes shows similar. Let's take example of chatbot and virtual assistants. When you ask Alexa or Siri a questions, embeddings help them understand what you are asking, even if you phrase it differently than they have seen it before. What's the weather and is it going to rain are different words, but embedding shows they are asking related questions. Next one is translation systems. So embeddings helps translation systems to understand that good morning in English should map to the buenos dias in Spanish, not just word by word translation, but meaning to meaning translation. Now we take example of content moderation. So all the social media platform uses embeddings to detect harmful content, even when people use creative spelling or synonym to avoid filters. The embeddings recognize the underlying meaning. So basic principle of embedding is words with similar meaning are close together. Like happy, joyful, delighted are clustered in one area. Sad, unhappy, depressed are clustered in another area. Car, mobile, automobile, vehicle are near to each other. Dog, puppy, canine are grouped together. Actually, embeddings use hundreds or thousands of dimensions, not just three, which allows them to capture the incredible nuanced relationship. But the principle is same. Similar concepts are close together in this mathematical space. Why embeddings are revolutionary? Before embeddings, computer treated word as discrete and unrelated symbols. Car and automobile were just different as car and banana, just different strings of letters. Embeddings change everything by giving a computer a way to understand that some words are similar and some are different, just like human understands. So this breakthrough enabled much better search engine, more natural chatbots, accurate translation systems, and all the more modern AI applications we use today. Embeddings are the bridge between the human language and the computer processing. They convert word into a number in a way that preserves meaning and relationships, allowing AI system to truly understand the language in a mathematical sense. So when ChatGPT understands your questions, when Google finds exactly what you're looking for, or when Netflix recommended the perfect show, embeddings are the working behind the scenes, helping the AI to grasp what you mean, not just what you said. This is all about embeddings and how they help AI systems to understand the meaning and relationship between the words. I'll see you in the next video where we will explore fine tuning, how we specialize AI models for specific tasks.